Okay, so it gives us a diagram of a graph that shows the straight line L1, and then it tells us we've got another line L2 which it doesn't show, but which is parallel to L1 and which goes through the point 2, 1. So the point 2, 1 is kind of, I don't know, about there. Whoops. The point 2, 1 might be about there. Okay. And it's telling us we've got a line which is parallel. So it's going to be a line which sort of goes, I guess, something like this, through that point. Like that. I haven't drawn it great, but something like that, and goes through the point 2, 1, and that we can call L2. Right, we want an equation for the line L2. Well, all we're going to have to do is to find the equation of the line L1, which I will call M1. Find the gradient of line L1, which I'll call M1. That gradient must be the same as the gradient of the line L2, because the lines are parallel, means that they have the same gradients. Now we've got 2 points on the line L1. We've got the point 8, 0, and we've got the point 0, 6. Now remember, the gradient is the change in y over the change in x. So the change in y is going to be 0 minus 6. The change in x is going to be 8 minus 0. And that's going to be minus 6 over 8, which is the same as minus 3/4. So that's our gradient. Now that must also be the gradient of the line L2. So we've got M2 equals minus 3/4, as L1 is parallel to L2. And we've got a point that L2 goes through, so it goes through the point 2, 1. So what we can easily do is do y minus 1 equals m lots of x minus 2. And then if we can expand this, so we get y minus 1 is minus 3/4 x. Minus 3 over 4 times minus 2 is plus 6 over 4, or in other words, plus 3 over 2. And then add the 1 on and we get y equals minus 3/4 x plus 3 over 2 plus 1 is the same as minus 3/4 x plus 5 over 2. And that's part A. Okay, so let's have a look at the next part. Line L3, so we now introduced another line, and that's perpendicular to the line L1 and goes through the point 0, minus 5. Right, so what does that mean? Well, it goes through the point 0, minus 5, which is a point that's going to be sort of down here somewhere, say about there, minus 5. But it's perpendicular to the line L1, so, and that means it's also going to be perpendicular to L2 as well. So if I wanted to, the question doesn't ask us to sketch it, but if I sort of try and sketch this on, it's going to go through. Interestingly, I don't know whether it's supposed to go through the point 2, 1, but it's going to look something like that, and that's the line L3, and we need the equation of L3. So let's have a look then. The first thing we need to do is to work out what the gradient of L3 is. Now, because it's perpendicular to the lines L1 and L2, the gradients, the product of the gradients, have got to give minus 1. And I could have written 1 or 2 here, because 1 and 2 are parallel, they've got the same value of m. So the value is minus 3/4. Minus 3/4 times m3 must give us minus 1. And remember, a quick way, I mean, you could just do minus 1 divided by minus 3/4, but a quick way to do it is to just look at it and turn it upside down and change the sign. So that's going to be 4/3. So we know that the gradient's 4/3. It goes through the point 0, minus 5. So we can very easily write the equation as y minus 5 equals the gradient 4/3 times x minus the x value at the point it goes through. But the x value is just 0, so we just have x there. And if I multiply through by 3, I get 3y plus 15 equals 4x. So my final answer is going to be 4x minus 3y minus 15 equals 0. And that's the equation of the line L3 written it. So L3 dot dot. So that's the equation of L3 written it in the form they want. A, B and C are integers because they are 4, minus 3 and minus 15.